Okay, so in this part of the video of the OpenFL GUI library, I am going to show you the examples in as they would look like in the Windows target, which is primarily the target that I wish to focus on, and of course other native targets like Linux and Mac. But if it works on Windows, then it's going to work in Linux and Mac, in theory at least. So let's wait for this to sort itself out, and then we will take a look at the label example, which is basically just a label. So as it's doing that, I'm going to take a look at the code here. So for a label, so we're going to declare a variable and we're going to set it to a new text control. Now the reason it's called text control versus a label is because text control is basically an extension of the control object, which is this here. In addition, it has a text field in it, which it then displays. Now the reason why is because text field inherits interactive objects. What it does not inherit is display object container, which is what we wanted to do. Reason why is because every single control extends from sprite. The reason why we want to do that is because we want to rotate things, we want to change things like orientation, scale, all sorts of manner of different things. Even though scale is part of display objects, but we'll take a look into that a bit later. So when you initialize a new text controller, it's going to say, okay, what's going to be the value of this text control? And the value is going to be, this is an example. Then we're going to take a look at a font to look for. So if you put embedded set as true, which by default is false, then you need to specify from your assets folder where your font is going to be. It will automatically add the .ttf in with the text control, so you don't have to. And then we've got font style here, so you can create your own font style if you wish. It takes 3 arguments or parameters. That's color, underline, and size. Default is a size of 11. It's got a default color of black, so that's why I've got text color is 0 times FFFFFF to make it white. And I'm going to embed fonts so that it will embed this font. Then I'll set the color. I'm going to set the location to this, well, not arbitrary location. There's a reason I did that, and the reason is this line here, line 37, label.anchor. So this was me basically testing the anchoring for this particular project. So the idea behind anchoring is that you can specify the relativity between the location of the control and the point at which you want the control to anchor to. So if it's bottom right, then the anchor point is going to be the bottom right hand corner of the parent control. In this case, it's going to be the stage, or technically this main class here. So let's take a look at that. This should have been built by now, yeah. Okay, so let's take a look and see what happens. So I'll double click on that. So here's the example. As you can see, I've got FPS running. Generally I am around about 90 FPS, but obviously that's because I'm recording screen and not GPU, so that's probably one reason why that's fluctuating at around 60 FPS, which is still fine. So we've got this example here. This is an example. Now when I resize it, the label is going to relocate to the bottom right relative to where it was previously. Okay, so that's what that anchoring is doing. And it does it automatically, so you don't have to. This is a bitwise OR, which means that you're basically saying, okay, I want it to anchor to the bottom and I want it to anchor to the right. And it's going to check those anchoring. Now, top left is already implied, so you don't need to do that. If you want it to be top left, you just need to get rid of this label.anchor, and that's it. If you want it to anchor to the bottom, then you just get rid of this, right? And if you just want it to anchor to the right, then you just get rid of the bottom of it. If you want it to anchor to the left instead of the top, then you will need to actually specify that. So you would do something like this: control.anchor left. And if that is the case, then it won't anchor to the top. Although the top bit is still technically implied, believe it or not. So, in essence, even if you just wanted to anchor left, it'll still be top left, because that's just how the underlying code works. That's something that I, as far as I'm concerned, have no control over. Unless, of course, I wanted to go into the internal workings of OpenFL, which I dare not to tread. Okay, so let's move on to the next example, shall we? Which is the TextBox example. Yes, text input now works in OpenFL 3.3. Thank you to the OpenFL community for finally making it work. That is amazing. It did work in Legacy, but Legacy had a few problems. There were a few functions that were missing, in particular get car index at point, and a few fields such as correct index was missing, which would have been good. Although apparently not necessary. Okay, so here we've got a text box example. Let's just let it do its thing. So now what I'm doing is I'm saying, okay, I want to specify a text field. I want to say this is the default text for when it first displays, and then when we create it, we're going to specify a width and a height, and that's going to be fixed unless, of course, we decide to change it otherwise. So if we wanted to, what we can say is we can say yeah, total width and total height, which specifies the height of the text box, and width specifies the bounds of the text box, as you can see. So you can do it that way, and that's fine. And then it'll redraw it automatically. And then we've got a style here. Now, the reason we've got this style is because we want to adjust the colors of it. Why wouldn't we? So we've got text color, and then we've got text color when we hover over, or when the control becomes active, essentially. Then we've got line thickness, so we can actually specify the thickness of the border of this control. And then we say, okay, the style of the text box is going to equal this new style that we created just now. Then we add it to the screen. So this should now be done, which it is. Okay, so let's go ahead and take a look at it. Now, I do realize this is not perfect by any stretch of the imagination. As you can see, the text box, or the correct position, doesn't really look right. It's a bit out of place. This is a broken text box. No. No. As you can also tell, it's when you're typing, this is some text I want you to see what I'm typing, but unfortunately it does not scroll automatically. I probably didn't run anyway, but even if I were to try and scroll it in that direction, I can't do that. So yeah, there still needs to be a bit of work done to this text box. As you can see, when we focus in on it, it highlights slightly. But so far, so good. We can, or we used to control A. We can control A in Flash, but we can't control A in Windows, which is not so great, but that's fine. That's fine. I'm okay with a little bit of imperfection, I suppose. But as long as OpenFL and its community continues to do well with improving the text input on native platforms, then all is well and good. So you can play around with that, the style, the colors. Got a button example here. Basically, now as you can see, I'm using math.random and I'm going to multiply by 848 and 480. So I'm basically saying, look, randomly locate wherever you want on the screen. I don't care where you are. It's going to contain the text click me. It's going to have this font here. It's going to have font style default true, and yeah. And then we've got a little bit more styling going on here. So we've got a new button style instead of text box style, as you can see here. And now when we click down, press down with one of our mouse buttons, is actually going to affect the styling just slightly. So let's build this and see the results of that. Now the auto sizing is done internally, which means that when you add more text or change the text of the button, then you will be able to see the button actually resize according to the new width and height of the text field that was put inside the button. So you don't have to do any of that. You can, however, did I implement auto size? I can't remember. I did. So you can specify whether or not it will be auto sized, in which case you will need to set the bounding height and the bounding width yourself. You don't have to do this if auto size is true. If auto size is true, you do not have to set that. If auto size is false, however, it might be a good idea to set that because it won't set it for you, and thusly it won't render. Or it might look like it's not rendering, but in reality all you did was leave the bounding width and height to 0, and obviously is the reason why it's not rendering. So that's something to consider when using the button. There is also another thing that you can do with the button, which is to specify an image location. So you have image align here. We've also got image source somewhere as well. Where's that? Oh yeah, icon location. So that gets or sets the path of the icon to show. This is empty, or the path of it, or the path is invalid. No icon will be displayed, and then you'll be able to align it. So valid values are, as you can see, left, right, top, and bottom. And the icon's width and height is going to adjust the button's width and height accordingly, and also relocates the text accordingly as well. So even if you have auto size off, it's going to do it automatically anyway. It completely ignores the value of auto size. So once again, something to consider. So let's take a look at that result in our button here. So as you can see, I can click on it, it has the effects, as you can see. You can hover over it, and yeah, you can, it basically is a button as you would expect it to be. Now I don't have any images to show you. I will probably demonstrate it in a future video. For now, I will leave that out of the equation for the time being. And last but by no means least, we do have the checkbox example, which is quite literally a checkbox. But unlike some checkboxes, you will be able to specify what type of check style you want. You can choose between 3 styles: a cross, a strike, and a tick. So let's take a look at each one, shall we? So obviously the first one is going to be tick. Again, same thing with the checkbox, set a value. The second parameter here is actually the default check state. So if it's false, then obviously it's not going to be checked when you first see it. If it's true, it's going to be checked when you first see it. And yes, I know, building to Windows while recording is not a good idea. And failed to update resources is currently a bug. I believe that's something to do with OpenFL 3.3. I'm not 100% sure yet on that one. Not sure why it's doing it. I've tried fixing it before, but it never worked. So let's take a look at it, shall we? So this is the example for a tick. So when I click on it, it's going to tick, and when I click again, it's going to not tick. As you can see, I can click as fast as I want, and yeah, I'm barely losing any frames. Although it is fluctuating, it's fluctuating between 50 and 60, which is a bit odd, but yeah. I mean, there's no real performance issues with it, so it is fairly optimal for what it is. Cross. So let's take a look at what the cross looks like, shall we? It is quite literally a cross, but let's just take a look at it anyway. No, not the cross like Jesus Christ, an actual cross like X, for example, the shape of an X basically inside of the control. Click it. And strike, which is the third one, is just like cross but with one of the strikes missing. You could probably figure out what that would look like. In your own time. Okay, so now let's take a look, and as you can see, it's now cross. Cool, right? Yeah, I like it. Okay, so let's take a look at the inner workings and see how it's all working. As you can see, I've got a layout engine here which is practically doing nothing, and I completely missed out the license. Wow. Copy that and paste it in here. Just a quick fix. Okay, let's take a look at text control, shall we? So this is what text controller is doing. It's going to create a new text field. It's going to have a font style. If the font style is null, then we're just going to specify that, yeah, the default is going to be black. It's going to be a size of 11. It's not going to be underlined. So, is that right? I actually can't remember. No, underline is that parameter here. I actually can't remember what these parameters are. But excuse me, I do apologise. So we've got embedded. It's going to check to see if this is true or not. If it is, then we're going to get the font from our assets folder. Otherwise, we're going to get a system font based on the name of that. So by default it's Arial. And that's given the fact that embedded is false and not true. Auto size is going to be left, so that it automatically resizes as you type or change the text. As you could probably tell when we took a look at the label example earlier, there was a bit of a trim at the end of the word example. Yeah, that's basically native text fields not working perfectly. Just to point that out. Then we're setting embed fonts to embedded. Text is value, it's not going to be selectable, it's not going to be multi-line, and then we're just adding it. And this is basically me getting bored out of my mind, copying every single property that the text field requires so that we can modify the same properties that the text field has inside of our text control, because it's required in order to work properly throughout. Let's move on to control, which is the meat of everything. So, some of this doesn't work yet, some of it does. Context menu strip, ignore that. Doc, ignore that. Tooltip, ignore that. Tooltip value, ignore that. Everything else, however, does work. We've got anchor, which, as you saw earlier, did in fact work. We can set the anchor to bottom right, and if we take a look inside of the setter, it's going to do a flag comparison, and I should not be doing that. Let's remove that. So in here we're doing a flag comparison. We're basically the flag comparison is current inside of original, and if it isn't, return false. If it is, return true. Basically what this operation is doing is it's doing a bitwise operation on these two ints. The end, it's not even a word. The ampersand basically says and. We're going to and current on original. So let's get our thinking caps on, shall we? Let's say we've got a logic table. So I'll just quickly use this example here using comments. So we've got a logic table, right? And in this logic table we've got and or. In that logic table we are going to have the value of current, which is, in the case of anchor right, is going to be 4, right? And let's say the original is equal to 12, because 4 and 8, obviously when you add it up, is going to equal 12. So if we have anchor right and anchor bottom in there, then it's going to be 12. Now, the reason we use bitwise operations instead of just adding and subtracting is because if we did it the addition and subtraction method, then we would also be including top left and top right, which is not what we want at all. The way in which bitwise operations work is that it uses a special kind of multiplication, let's say. So it actually takes into consideration the amount of bits required to get to a particular value. So the bit value of 4 is something like, I can't even remember binary now, what's wrong with me? So bitwise operations, right? We start at 1, 2, 4, 8, 16, 24, 32, 64, and it goes on and on and on, right? So if we have 4, then it's going to equal 0, 0, 1, 0, right? Like that. Although technically not in that order. Technically it would be written like this. That would equal 4. And so what we're saying is, when we add that, we want to basically say is 0, 1, 1, 0, 0 inside of this one, which is going to be 1, 1, 0, 0, because we've also got an 8 in there if we're obviously going to set it to bottom right. So when we're ORing it, so when we OR anchor right and anchor bottom together, we're basically saying so anchor right, which is 8, ORing to anchor bottom, which is 4, or it could be the other way around. That is going to then equal 12, and in its binary form is going to equal that, right, which is this value here. When we're ANDing it, what we're saying is kind of the opposite. It's kind of like subtraction, in the sense that when you do whatever the result of anchor right and anchor bottom ORed is, which is 12, when we do an ampersand on that and saying ANDed with either anchor bottom or anchor right, it's going to say, yeah, this is included within that operation, therefore we're going to return true, right? If that makes sense. If we did an operation like, say, if we did a flag comparison in that instance of anchor top, it's going to return false. And the reason why is because when we ampersand the top value, which is 1, yeah, then that's not going to be included, because the value of 1 is 0, 0, 1. And when we AND it on here, that's then going to equal this. but that does not equal, this does not equal that, right? Does that make sense? So that's why we use bitwise operations, because that way we can actually tell between them, between the flags. As you can tell, I tried to do a docking system, but I decided to give up eventually. So when the stage is resized, we're going to do a flag comparison. We're going to say, okay, x is equal to the previous difference minus its width and the stage width, right? So it's basically saying what you saw earlier with the label. So that's the internal workings of an anchor. As you can see, the default is actually in fact top and left. But what you can do is actually specify a different value, which is what you would expect. Okay. If we go down to TextBox, I'm going to take a look at that. Now, in order to do the effects of sort of moving the text box left, yes, left, as you're typing, so that you can see what you're typing as you're typing it, you would set the auto size to none, you would set multi-line to true, and you would have obviously selectable as true so that you can obviously input in it. So the idea of multi-line being true is because, well, we want to be able to see what we're typing as we're typing it. Now obviously, as you saw in the Windows target, it doesn't actually work, so that's kind of out the window and kind of annoying, but at the same time hopefully there will be a bug fix for that, so that would be all good. And when we add to the stage, we're going to redraw, and the redraw function is going to cast the style onto a TextBox style class. Now the reason we do that is because we want to determine whether or not the style actually has a value. If it doesn't have a value, then we're not going to cast it, because obviously it would be not, if it's null, then it's not going to do anything, right? Then we're going to clear it. We're going to check to see if it's casted or not. If it has focus, then we're going to change the values again for the active effects, and then we're going to change the values again if it doesn't have focus to the non-active effects, and then we're going to provide some default values in other instances. And yeah, that would actually look kind of ugly, as you can probably tell. And then we're just going to draw the rectangle in order to draw basically what the text box would look like, essentially. Moving on. Next. What was, yeah, button. Just move over here. So you've got auto size, as I mentioned earlier, and obviously you can set the text, you can set the bounding width and the bounding height. You can set the icon location, as I mentioned, the image align. So let's take a look at that. Now this is, now I understand that this probably looks complex and this probably doesn't work, so I'll probably do some testing before I decide to actually do the demonstration. But obviously the idea is I add an image to a specific location or layer, let's say index, inside of the display object hierarchy. The reason why is because I want it to be topmost. I want it to be covering as much of the button as possible without otherwise breaking it in a way. I did a little comment here, native Nico will crash, the location is invalid. So when we do assets.getImage bitmap image, what tends to happen, especially in Nico, is if the image cannot be found, it'll actually just crash. Right, we don't want that, so we'll just encapsulate it in a try, and we're just going to leave an empty catch. We don't really need to provide a message to the user. We could if we wanted to, but if the icon location is missing, they would probably know anyway, because the icon wouldn't appear, right? And then we're going to do some calculations. So if the image is not null, then we're going to say, okay, the total width and total height is going to equal the width and height of the image. We're going to set the word wrapper of the text field to true, so that the word wrapping is specified. And then we're going to also specify the width. The reason why is because we want the word wrapping effects to take place. Then we're going to add a bitmap, which, by the way, I know is inefficient. I should really use bitmap data and copy the pixels over, because that would be a bit more efficient, otherwise known as blitting, but we can take a look at that in further detail in a later video. And then we take a look at the image align, and we're just going to say, okay, if it's left, then we want to align the image to the left, and we want the text field to appear on the right side of that image. Same with right. We're going to have the text field appear on the right side of the image, and the image is going to be aligned to the right of the button. Same with top. The text field is going to appear below the image, and in the case of bottom, the text field is going to appear above the image, and the image is going to appear obviously at the bottom. And we're going to add the bitmap. If there is no image, then we're just going to say, okay, word wrap is false. We're going to re-specify the width, the total width and the total height, which is going to be equal to the bounding width and the bounding height. So this is what I meant by the bounding width and the bounding height all automatically being set in this case. And auto size, if that is on, then the total width is going to be set anyway to the width of the text box plus 4, which is essentially padding, really. And then we redraw the graphics. So now, with a bit more fun, we're going to now take a look at the checkbox. So if we go down here, we've basically just got one variable here. You've got text, which you can set the text of the checkbox, as you could probably assume, and then checks. When you set that to true or false, then it's going to obviously redraw and specify. And when you specify cross, strike or tick, it's actually going to draw the lines required in order to allow that to appear the way that you would expect. You're probably wondering what these move to's are for. So the move to operation allows the registration point of the graphics component to move the the registration point to a specific location. When you do line 2, it's going to then draw a line from the registration point to the point that you specify in line 2 or curve 2, like here for example. Now when you do graphics.end fill, for example, it says here at the bottom, if the current drawing position does not equal the previous position specified in the move to method, and the fill is defined, the path is closed with a line and then filled. So in order to prevent that from happening, we actually have to specify move to for each operation before we decide to then do line 2 again, because if we don't, then it's going to end up completing what is otherwise a shape. When I actually did the tick, it actually appeared as a triangle because I didn't realize that I needed to do that. So it actually looked like that to start with, and I'll even show you the results of that, just to demonstrate the effects of that. this is going to take a while. And then we're just specifying the text, color, and the location as required. I've also got a Boolean value here, which is can style, so I'm using the question mark here to say, okay, I want you to operate this and evaluate it. So everything on the left hand side of the question mark is going to be evaluated. If it's evaluated to true, then the first portion before the colon is the value that we're going to use. If it's false, then we want the value after the colon. So anything before is true, anything after is false. And as you can see, this is just some simple operations. As you can also tell, this code is a bit more efficient than the other controls. Probably wondering, how is that more efficient than this? Well, for starters, there's quite a lot of code repetition. As you can see, I'm having to repeat it both here, lines down, begin fill, and here, lines down, begin fill. The better way to do it is to do it the way I did it in Checkbox, which is doing a var outline color here, fill color, text color, blah blah blah. Checking to see if it's down. Okay, can we style it? And basically, when we say can we style it, we're basically detecting to see if the casted object, which as you can tell is this one here, is null or not. If it's not null, we can style it with the style that we used. And we're setting it. Should be done now. Okay. So now, let me take a look at it. I will now show you the results. Oh, it's not tick, is it? God damn it. No, it's cross. Damn it, I did not realise that. Yes, I do realise Skype is calling for me. Or someone is anyway. Using the power of video editing technology, I shall speed this part up, I believe. Okay. See what I mean by the shape of the tick? Well, it doesn't look like a tick now, does it? It looks more like a triangle. So yeah, gotta be a bit careful about that. So let's go back to our checkbox and return it to what it was before. So that's why you have that move to there, because otherwise it'll cause things like that to happen. So I hope you all enjoyed. Thank you very much for watching. That was a demonstration of the OpenFL GUI in a nutshell. Currently in its current in its current state, and hopefully some of you might decide to start using it. Otherwise, I wouldn't be developing it, but you know. So, once again, thank you very much for watching. I hope you enjoyed, and I will see you next time.